I would like to introduce myself. My name is Solange. I come from Brazil, from the city of São Paulo, which is the biggest one here in Brazil. I'm a chemistry teacher and I have been working as a chemistry teacher for 20 years in high school and higher education as well. Currently, I have been researching on the topic metacognition, which I think it's very fruitful for our students. Today, in this conference video, I would like to show an example of this kind of strategy, and you can use in your classroom with your students, either high school or higher education. I have already done with the both of them and it works very well. Okay, so let's get started. I hope you enjoy the presentation. Okay, well, here's what I call a chemistry modeling activity, which can be an example of a metacognitive strategy. The purpose here is to construct the initial concept of chemical transformation between metal and ions, considering the transfer of electrons. Target audience could be high school or higher education students. Depends on the focus you want to give. I have already done with these two possibilities. Here we have a summary I have prepared here with the parts of the presentation. Part 1, I will talk about some aspects of metacognition. Part 2, some aspects of POE, predict, observe and explain. So, these first two parts refer to the theoretical foundation of the activity. I think it's very important to understand the purpose of the entire presentation. So, part 3, the activity itself, which is an example of a metacognitive strategy, learning about oxidation reduction reactions. And finally, we have part 4, which refers to final considerations. Part 1, some aspects of the metacognition. Do you know how do people learn? What's the most important factor in successful learning in your opinion? I will show you 5 options and I would like you to choose just one, which for you is the most important. All of them undoubtedly is important, all of them, but I want you to choose just one. Here we go. Yes, what you think about while studying. This is the most important. Well, why? Students must not only learn the concepts, but in addition, they need to develop a framework of connections among the concepts. They need to know how ideas are linked together and what makes them similar or distinct. Dr. Shu is a psychologist and researches on this subject, trying to understand how do people learn. And what is metacognition? I like this image. It's a metaphor. Well, what I'm talking about is like if you have an outside brain controlling your own brain. Yes, something like this, just to understand. Metacognition, we can think about your thinking, but it's more complex than this. According to Flavio, metacognition refers to one's knowledge concerning one's own cognitive process and products, or anything related to them. Later, in the same page of this text, he brings more two words, regulation and monitoring. It's very important for the students to construct their ideas. So, the students have to monitoring to realize what's going on and what's not going on. And so the possibility for him regulate his ideas or her ideas. Part 2, some aspects of POE, predict, observe, and explain. Ricky and Stasi wrote an article on chemical education about metacognition, and they consider the POE strategy as metacognitive one. It's an example of this. Predict. First, you have to predict. Say what you think will happen in the phenomenon. It will react, it will explode wherever. Observe. In the sequence, you observe the chemical phenomenon. Explain, then you propose explanation for what you have observed, in case they may be at the symbolic level or the submicroscopic level, because we are talking about chemistry, and this feature is very important. 2 essentially metacognitive steps could be added. I suggest rethinking and re-explaining. Part 3, example of metacognitive strategy. The activity itself. Learning about oxidation reduction reactions. Let's get started then. And I will show you an example to apply with the students if you want. Activity design, to have an idea of the whole activity. First, students will predict what they think will happen when steel wool is added to a solution of sulfuric acid. Just an example, you can use another mixtures. Stage of observation of the phenomenon. It can be an experiment done with them or a video that shows the experiment. I have done already both of them, and it works as well. From observation, they will resume their ideas and propose an explanation. Metavisual stage, it's my favorite stage. They will confront their explanatory hypothesis with a scientifically accepted model for the phenomenon, and they will rethink their concepts. Now the task is to re-explain their ideas, seeking an adequate reconstruction of ideas. The first one, let's get started. Students will predict what they think will happen when steel wool is added to a solution of sulfuric acid. Here we go. You can ask 2 students, what do you think will happen when steel wool is added to a solution of sulfuric acid? And so you have a time for them to answer this question. They will discuss probably about 2-3 minutes. Okay, they have finished. So the stage of observation of the phenomenon, it can be an experiment done with them or a video that shows the experiment. Here, of course, I will show you a video that I have produced specifically for this activity. After watching the video, comment freely on your impressions, comparing with what you thought before, Was there a chemical reaction? Between whom? This is the questions you can ask to your students after watching the video. Now they will have to explain what they have seen. From observation, they will resume their ideas and propose an explanation. To students, propose an explanation model by drawings, symbolic and submicro. A. Symbolic level, write a chemical equation of the phenomenon you have observed. Submicro level, draw particles using balls. You can use Dalton models. Here's an example, initial, final. Legend is very important to understand what they are proposing. Another step, rethink. It's very important to have a time here, about 10 minutes, 15 minutes, for they construct their purposes. Now we have metavisual stage. They will confront their explanatory hypothesis with a scientifically accepted model for the phenomenon, and they will rethink their concepts. It's very interesting because I will show an image, and they will think about this image, and the image is in their minds. You can say to students, compare your hypothesis with the following drawing. Here we go, equation, and which represents the symbolic level, and we have the submicro level. The students don't need to do exactly as we have here. It's just a representation of the phenomenon, a possibility. It's not the unique one. Now they will have to re-explain. Now the task is to re-explain their ideas, seeking an adequate reconstruction of ideas. To students, identifies differences and similarities, attempting to rebuild or ratify ideas. Here we have students' hypotheses, for instance, 2 examples from my students. The first one is here. They have represented here symbolic level and submicro level. Symbolic level, we can see here the charge of the iron is not correctly, and the stoichiometric coefficient is not correct as well. Here you can see just one particle reacting. We know that there are many particles reacting. The second example, another group of students, they are doing very well as well. Here the submicro level and the symbolic level. Note that it's not important if they are right or they are wrong, because their mistakes are very important, because you have to construct the knowledge from the prior knowledge of them. So it's very good if they are right or if they are wrong. You are going to mediate this construction, and so it's okay. And here we have some reference I have used in this presentation. Hi, and that's the end of the presentation. I hope you enjoy it, and probably you will apply with your students. If you have any doubt, any questions, I will be very happy to help you, okay? Thank you very much. Bye.